Okay, probability. Let's say that you are a 75% free throw shooter. You are not bad. You get 3/4 of them in, and you get 10 shots at the end of the game. 10 shots. Why the heck would you get 10 shots? Well, they fouled you a whole bunch of times because they were behind, and they keep fouling you to try to stop the clock, and so you keep getting free throws. You end up getting 10 free throws at the end of the game. Well, you know you can't make 7.5 free throws, right? So here's the question, though. What's the probability of you making 8 out of the 10 free throws? Let's see if you learned how to do binomial well enough. A hint, it's kind of the bones of it look like this. I said you're a 75% free throw shooter. And the question is, if you get 10 shots at the end of the game, what is the probability that you will make 8 of them? Anybody else need a calculator? I'll pause for a second while I hand out a few calcs. All right. You should have said 10 shots, choosing to make 8. 75% chance of making it. That means 25% chance of missing it. And then these two numbers, I'm going to make them blue question marks. They need to add up to what? To 10. So I wanted to make 8. So if you set this up with always this being the successful one, then this can go here. Does that make sense to you? And if they have to add up to 10, then that must be a 2. Any questions on that? Okay. Then hopefully you have a decimal for this. And it's not very high percentage. Why not? The guy shoots 75%. All this is asking is that he makes 8 out of 10, which is like 80%. Shouldn't that be extremely likely? Well, like kind of. Yes. Exactly 8 out of 10. So what could it be that would have been close to that? And it wasn't that, but what could it have been that was really close? All right. I must be asking the question in a strange way. Do you get that there's other things he could have gotten that would have been really close to 75%? Like 7 out of 10? Now, I'm not going to make you go figure it out right now. I just asked you to do this one. And that was a final answer. What did you get, sir? And we're always going to go 3 decimal places, so that's good. Raise your hand if you concur. Okay. Then there's about only a 28% chance he's going to make 8 out of 10. Doesn't that seem weird? Doesn't it seem more likely than that? Well, that's because there's a fairly good chance he's going to make 7 out of 10. Would you go through and just change one little number, just redo your calculations, except figure it out for 7 makes? I'll pause for a second and try that. In case you were checking yours, it should have been 10, choose 7, 0.75 to the 7, 0.25 to the 3. Take a second to type that in the calculator. You always take the same number of shots. We took 10 shots at the end of the game. Now, we could change the problem completely and say he only took 9 shots, but that would be a different problem. All right, so when you put it all together, this one, well, is it more or less likely? Or is it equally likely? 0.2 what? 250 if you're going to round it to 3 places. All right. Do you get, if I ask the question, what's the probability he will make 7 or 8, that you would add these two? Do you get that there's about a 52% chance or so that he'd either make 7 or 8? That still feels low to me. But why? Because there's all these other options. Could he make 9 out of 10? There's going to be some small percent chance of that. Could he make 10 out of 10? Yes. Could he make 6 out of 10? And if I added all of these things up, it would add up to 100%, right? What's something that's really unlikely? Making 0. All right. So then what's a question where we'd say, well, what's probability of making 0 except in a different way? At least 1. Think about that for a second. At least 1 would mean 1 or 2 or 3 or 4 or 5 or 6, but you don't want to have to do all of those and add them, right? At least 1 means the same as not 0. So you figure out the probability of 0, and then not that. Not something means 1 minus. So if I want, let's say the chance of rain today is 60%. What's the chance of not rain? 40, because it adds up to 1. So you take 1 minus the 0.6. 1 minus is the same as not. All right, so here's the probability of getting 0. 10, choose 0. 0.75 to the 0. 0.25 to the 10. That means a really, really small chance. 1 minus the really, really small chance is a really, really big chance. So that should have rounded to 99.9%. Probably 9999, I agree. Okay, let me give you another one that's a lot like what I just said. Let's see if you can handle this. We're changing the problem. This time you get 2 shots at the end of the game. The kid's a 90% free throw shooter. What's the probability he makes at least 1 shot? I immediately would change that to either 1 or 2, or what's another way to say at least 1? Not 0. Okay. I'm going to say that one more time. He gets 2 shots at the end of the game. He's a 90% free throw shooter. A really good free throw shooter. What's the probability he makes at least 1 shot? Would you compare with the kid next to you once you get the decimal? Put the decimal in on the calculator. I'll pause for a second while you try that one. All right. I'm going to do the not one, which is 1 minus whatever. So I'm going to do the not 0. Here's the probability is 0. What's 0.1 times 0.1? Well, that's a lot like 1 times 1, which is 1. But then you just got to put the decimal in the right place. And if it's 0.1 times 0.1, there's 2 decimal places. 0.001. What if I take 1 minus that? 0.999. You get there's a 99.9% chance that this guy is going to hit at least 1 of the shots. Did that make sense to you? Is the decimal wrong? Could be. Uh-oh. 0.1 times 0.1 should be 1, and then move the decimal 2 spots. Oh, I moved the decimal 3 spots, didn't I? Okay. 1, and then move the decimal 2 spots, not 3 spots, Mr. Server. Okay, and then that means 0.01 is 1% chance, and therefore 1 minus 1% is 99%. Thank you for correcting me. I just had the decimal in the wrong spot. Okay, one more like that. Ready? Now, kid's going to take 4 shots at the end of the game. We're going to get the same kid. He's a 90% free throw shooter. He gets 4 shots. He needs to make at least 3 out of the 4, and then they win the game. If he can make 3 out of the 4 shots, at least 3, we'll be happy if he makes 4. At least 3 shots. He's still a 90% free throw shooter, so right away you go, oh, 90, 10. And there's a C in front of it. At least 3 shots. You can't do this one with a not. That really only works when it's at least 1, because then you got a 1 or 2 or 3, and the only thing that works well with is if they say at least 1. Then you want not 0. All right. He's got how many shots at the end of the game? 4, and he wants to make how many of them? At least 3. So 3 or 4 of them. This goes here, and this plus this adds up to this, so that's a 1. And this is 4 and a 0. There's a decimal for the top one. There's a decimal for the bottom one. Mr. KH, what did you get for the top one? A little louder. Point what? 292. Can anybody verify 292? Okay, good. And how about the other one, Mr. EB? Anybody verify 0.656? Okay. Do you get that this or that would make us win the game? And therefore I put them together. And there is a 60, 70, 80, 94 point something, 0.8, 94.8% chance? 95% chance we're going to win the game. Make sense? Okay, now, that's all the old stuff. But that's tough stuff, so I definitely wanted to go over it again. So what's the new stuff for today? The new stuff for today is called expected value. And the first thing I want to say about this is that it's kind of like fair value. I'll give you an example. If there was a game where I would pay out of my wallet a random bill from my wallet, I would close my eyes and I would grab a bill out of here and I would pull it out. I honestly don't know what I'm pulling out right now. Ooh, it's a 20. All right. Now, you don't know what's in here, and of course, you guys are naturally suspicious, so you'd probably say, oh, he's probably only got 120 in there, and the rest are like, you know, nothing, $1 bills or whatever. So you'd want to know the details, but would you pay a penny to play that game? Again, I know you're suspicious, but if I just said you could do that right now and grab a random bill out of my wallet, would you pay a penny? Well, you should. It's just dumb if you aren't willing to risk a penny to have a chance at any bill. Any bill is going to be more than 100 times your value. If you couldn't say yes to that, you're not thinking. All right, so how about this? Would you pay $20? Yeah, it's a little risky. What if I told you I had 10 $100 bills and only one 20 in my wallet? Now would you pay? Yeah, you pretty much can't lose because the lowest bill in there is 20 bucks. So, okay, so I'm going to make this, again, back to reality. I don't have 10 $100 bills in here, okay? So let's imagine for a moment that it was whatever happens to be in my wallet for bills, okay? Then what do you think is the fair price to play the game? Well, a penny's no-brainer. You should do it. It's a great deal. $20, probably a little too risky. I'll tell you in a minute exactly what the bills are, and then you can calculate exactly what the fair value is. But do you agree that somewhere in there is like the fair price? That's what expected value is. All right. I'm going to tell you the details now, and then before I tell you how to do it, I want to get your guess then. What if I tell you there's one $100 bill? What if I told you there are 6 $20 bills? And let's say I told you there was 2 $1 bills. Would you pay $1 to play the game? Yeah, easy. Great deal. Would you pay $20 to play the game? Ooh, I like that logic. He's saying there's 7 out of 9 chance that you're going to at least make your money back. So he's saying, yeah, he'd pay 20 bucks. Okay. Write down what you think without doing calculations. I'll tell you in a minute how you figure out exactly, but write down what you think is the fair value. What's the fair price for this? As in, it would be a complete break even on the average in the long run. What's the fair price? It's like $17.56, or is it like $29.12? What do you think the fair price to play this game is? That's what expected value is. It's if we did it like 1,000 times it's going to be the average payout. If we tried it like 1,000 times, it'd be the average of how much the game paid out. So expected values are averages. All right, last thing. Here's how you get your number. First of all, if you haven't written a number down, write it down, because I don't want to tell you the formula for getting this, because then you can just use math to get it. I want you to have your gut feeling. Okay, if you haven't already written it down, write it down, and then show somebody nearby what you think it's worth. Let's see who's closest. Who has an answer close to $5? 5, 6, 7, 8, kind of in that zone. Who's in the 9, 10, 11, 12 zone? Who's in the 13, 14, 15, 16 zone? A couple hands. Who's in the 17, 18, 19, 20 zone? Who's in the 21, 22, 23, 24 zone? Who's in the 25, 26, 27, 28, 29 zone? All right. That's most of you guys, and it's in there somewhere. All right, I'll show you the exact answer in a second. Okay. It's P times A, then add. I'll show you what that means. Take a wild guess what the P stands for. Probability. What do you think the A stands for? Amount. Average was a good guess, but amount is the correct answer. Probability times the amount, and then you add. Would you agree that this $100 bill here has a probability of 1 out of 9 chance that it would be that? And then what's the amount you get if you grab the $100 bill? 1/9 times 100, and that's a decimal. Next, I do it again. Probability of this one. 2 out of 9. And then you multiply by the amount you get. $20. Sorry, that's not 2 out of 9. 6 out of 9. You're right. And last but not least, 2 out of 9 chance. And the amount you get for this dollar bill is $1. Probability times the amount, then you add them all up. Okay. Would you please figure out the first one, Miss V? Would you please, Mr. EB, figure out the second one? Would you also pick on the front row 2/9 times 1? I can do it in my head, except I want the decimal for it. Pretty sure I know it, but I'd like you to figure it out. What is that first one? It's V. $11 and 11 cents? 11.11. Raise your hand if you had 11.11 for that first one. Oh, not everybody did it apparently. How about you, Mr. B? 13 point what? That's the value of just the 20s that are in there. And remember, it's P times A, and then we're going to add them all up. What'd you get for the last one? 22 cents for the last one. Add it all up. $24. And 66 cents. Did I add that right? Who is the closest to $24.66? Okay, exactly. Who is it? 24 point something. Who actually had 24 point something? Oh my gosh, what did you have? 24.6. Who is anybody closer than that? Also 0.6? 0.67? 24. You guessed $24.67. Are you can't be serious. Oh, so you knew how to do this ahead of time. Okay. So basically you used the calculator. That is not what I was going for, but I'll give you credit. You obviously figured it out. Who did it without a calculator and still got really close? All right. I'm giving credit for both as being very smart. That's awesome. Okay. If this was a casino, they would not charge $50 because people aren't morons. People wouldn't go, well, I'll play that game. I want to lose a lot of money. Okay, there are some, yes, I know. But casinos price it so that they have an edge. They never price it so they're going to lose. Do you know what the closest thing is that they'll do? There's one bet in the whole casino. We're talking like the legit kind that are out in Las Vegas. There's only one bet that's even close to fair, and it is this certain bet you can make in a roulette game, and it's only one of many bets you can make, and it's the only fair bet on the whole of Las Vegas. And all it does is give you exactly a 50% chance of winning. In other words, it's still not an advantage to you. It's just exactly fair, and it's only one bet on that whole green table of felt, and that's a 50-50 bet. Okay? And people that know how to play that game, that's the one bet that they bet a lot on, because if you're really there to have a chance of winning, then that's your best chance of winning. And your best chance of winning is a 50-50, so to speak. And that's in roulette. All right, anyway, that's not roulette. I'm sorry. That's in craps. It's in craps. The big table with the dice. You roll the dice. Craps has the only fair bet. It's always worse than that everywhere else. So the casino might even charge you $25 to play. The fair price was $24.66. They're only going to charge you 34 cents to play. But if you play 1,000 times, that's how they make the money, is on a ton of bets. A small edge. All right, one more like that. These phones, almost everybody has a phone nowadays. And these phones obviously have a chance of breaking. If you have a history of breaking phones? Oh, it's just shattered badly? Okay. Okay, all right, destroyed phone. That's even worse than just shattered. All right. So, do you get that they sell insurance for that? It's called AppleCare. Now, that's if you have an Apple. Not everybody has an Apple, but I'd say it's almost everybody has an Apple. Anyway, yeah, like one kid. Anyway, so AppleCare Plus, if you drop your phone, they will replace your phone for you. Granted, there is a deductible. In the old days of AppleCare, it was simple. If you bought the insurance, then you just brought them your phone, and they gave you a new one. It was completely free. But the problem was there was too much usage, because people really all of a sudden didn't care at all about being safe with their phone. You know, kids would be like, "Watch this! I got insurance." And I can shatter their phone. Like, I'm going to the Apple store tonight, so why not? You know, just to impress their friends. So they decided to throw in a deductible, it's called, meaning that you have to pay, and it started at $50, and now I think it's $99 deductible. So that on the newest iPhones, even if you buy AppleCare, you still have to pay $99 to get your screen fixed. Okay, but we're going to keep your life a little simpler. We're going to go back about 5 years before, when they didn't have any deductibles, and we're going to give you two things that could happen. You're going to buy the insurance, and either your phone is going to work, or it's going to break. Let's say there's an 80% chance your phone will just keep working, and there's a 20% chance your phone will break. Now, we totally have to make up numbers, because I don't know these numbers, and Apple doesn't even publish these numbers, because if they did, some blogger would be able to figure out very quickly, if you just tell me what percentage of the phones are breaking over the course of 2 years, I can tell you exactly what the fair price of AppleCare should be. It'd be easy to do that. And then they don't want that published, because as soon as they find out the fair price of AppleCare would be $89, why do they charge you $189? Because Apple wants to make a profit. Shocking.
Really?
They want to make money? I thought they were just doing this for fun. All right. So if the phone works, what do you get? You walk in there after 2 years and you say, "Hey, my phone's still working." What are they going to give you? Nothing. Okay. So you get zero. In fact, I want to warn you about this. On the key, they do this a little differently. This never made sense to me, so I didn't want to do it this way. They'd say, you not only didn't make anything, you wasted the money of the warranty, so then you made a negative amount. If you see that on the key, you can ignore that. Your answer should come out the same if you do it my way, which is easier. It's not going to talk about making negative money. All right? On this end of things, if your phone breaks, we're also going to make your life simple and just say that they give you a new phone valued at let's say, I don't know, let's say $500. Not everybody has the iPhone X. A lot of you guys have like a 7. And I don't know, we have to figure out exactly what the average would be. I'm going to call it 500 bucks. Okay. So what did I say the formula was for these again? P times A and then add them. What's P times A? That times that. What's P times A there? 0. That's one of the reasons I like not having any other numbers there. Because watch, when you times by 0, you get 0. It's awesome. That's just gone. How about this? P times A. I can do it in my head. 2 times 5 is 10. Do you think it's $10? Now I got to move the decimal to the right spot. How about 100 bucks? Yes. That means the fair price of this warranty was P plus A. Sorry, P times A and then add. 100 plus the 1 is the fair price was $100. What does Apple actually charge for Apple Care nowadays? No. I'm going to say on an older phone, it's probably $129. So how do you put those together? You are going to lose money. That's why they put a negative amount in the key up on the 0, because they're saying if you bought the warranty, you're still going to lose money. I like to put it at the end, minus 129. Because look at how easy this was. 2 super easy numbers. That one was 0. This one's 100. Add them up. That's super easy. We just got to remember to subtract it at the end. Final answer, you lose $29. That means your expected value of the warranty was negative. That means it wasn't very smart of you to buy it because you lost $29 and Apple made $29. Does that make sense to you? Now, the real world is much more complicated. Apple really kind of wants people to buy the warranty because then they have happier customers. Because then when your phone breaks, you walk out of the Apple store feeling happy, like, hey, I got a new phone. This is awesome. It's actually better than it was 2 months ago because it's got a new battery and yay, this is awesome. So people walk out happy. They want people to be happy, okay? But they also want to make money. So they want to set the price just right so they make a little bit of money, but not too much money. Sound a little bit like the casino. They want people to make, well, they want to make a little bit of money. But they want people to be happy enough to keep coming back to the casino. If people lost half their money every single time they went in the casino, they would stop going to the casino right away because they'd be like, this sucks. I always lose. I'm done. They need it to be fairly rewarding so you'll keep coming back. All right, I'm not saying Apple is a casino. I'm not saying that. I'm saying that they both price it so that they make money, but not ridiculous amounts of money. All right, one other thing that happens in the real world, when Apple repairs your phone, do they actually have to pay $500 to get a phone? No, their cost of making a phone is way cheaper than that. So when they give you a new phone, it's like not that big of a deal to them because they make them. And so it doesn't cost them that much. So they make even more money than it even looks like they make. So they make a lot of money on warranties. And if you've ever been to like a Best Buy and you walk in and buy a TV, you always get asked at the register, would you like to buy a warranty with that? Why? Because they make a lot of money on warranties. All right, but does that mean it's stupid? I don't think so. Because if you are willing to, on average, lose money on this, the good side of it is you get some peace of mind. I have personally bought the insurance for my phone because I'm scared that I'm going to drop the thing. And that makes me like, oh crap, I've got to be really careful all the time. Because if I do drop it, it's going to cost like $400, $500 to repair it. That sucks. I want the insurance. See what I mean? All right, so it gives me some peace of mind so I don't have to worry about my phone all the time. But that's what it's costing me. At least I know what the peace of mind is costing me is on average I'm going to lose $29 over the course of 2 years. That's about $15 a year for peace of mind. People do that all the time. Technically, you don't even have to buy car insurance in Minnesota. You can post a bond and basically show them, I have enough money in the bank here that if I do have an accident, it would pay out the state minimums. So you can even not have to buy insurance, but almost everybody does. Why? Because it gives them peace of mind. You'd be a little bit scared that what if your kid plows into somebody and they happen to hit the Maserati and you got to pay like $80,000 to fix their car. Even if you got plenty of money in the bank, you don't really want to repair the guy's Maserati. So you buy the insurance because you get peace of mind. Okay, so let's look at the homework. Everybody get there. I'll pause for a second while you find the worksheet for today. It's the last day. It's called expected value. Okay, here we are on the expected value worksheet. First off, you know I try to cut these down to keep them reasonably sized. So here's the ones you can chop out. You may, and this will save you a bunch of time, skip problem 3. Look at all those parts. A, B, C, D, E are out. And you may skip problem 7, lucky 7. It's not like those are bad questions. Those are good questions too. But I think you'd be okay if you did every other problem. Those are the strategically skipped 3 and 7. Okay, look at number 1. Remember, it's P times A and then add them up. What's the probability that you pick a random house and it has 2 people in it? 350 out of how many houses are there? It says in the directions, there's 1,000 that you could pick from. Then there's 350 out of 1,000 chance, that's the probability, times, this isn't an amount of money question, this is an amount of people question. So it's P times the A. What is the amount of people in those families? 2. And then you get a number for that. 350 over 1,000 times 2. If you want to be strategic on the calculator, you could say 35 over 100. Or if you really were smart, you'd say 0.35 right off the bat. Think about that. 0.35 times 2. And I can even do that in my head. 0.35 times 2. Well, it's 35 times 2, which is a 70. So then the question is, do I really want to do 70? Well, it's got to be some percentage of 2. It's got to be way less than 2. So it's 0.7. Is that the answer to the question? No. That's just the probability times the amount for the first one. That one's 0.7. This one is 3 out of 1,000. Sorry, 200 out of 1,000. Cancel off a couple zeros. 2/10, that's 0.2 times 3 is 0.6. That was the P times the A. And now I'm starting to add them up. 0.7 plus 0.6 plus this one. 4 out of 1,000. That's 0.04 times, I'm sorry, 245 out of 1,000. 245 out of 1,000, and then I times it by 4. I got to pause while I use that calculator. All right, came out to 0.98 for this one. And I just keep a running total like that, and I get a grand total at the end, and that's the expected value. I would expect the value to be bigger than 2 because the smallest family I have is 2. Like, they aren't picking people with single households. It's only people that have 2 people in the household. So, grand total, anybody got it yet? What did it come up to? 3.403. Once you've added all these up, and that means what? There's 3.4 munchkins running around in my basement? Nope. 3.4 chickens? Nope. 3.4 is the average household size. Is that true in the real world? Well, it depends on where you ask. We totally made up this data. Okay. Are there households that have 0 people in it? There are vacant houses, yes. Are there households that only have 1 person? Yes. So, is the average really 3.4? I really doubt it. In certain places, it could be. Okay. Next. They've already said the men have a mean height, average height of that. The women have an average height of that. And what is the mean height of the 100 math petitions? Well, there's 2 ways to do that. There's the men and the women. And I bet you anything there's a P times an A, and then you're going to add them. What is the probability you'd pick a man? 72 out of, I think it adds up to 100, doesn't it? So then the probability of the man is 0.72. 72 out of 100. Times the amount. Well, the amount of height we're talking about here, the amount you get if you get a man, on average is 1.79. That's P times A. You get an amount. Then we do the P times A for the women. And then we'll get an amount. And then we add them up. P times A, then add. There, you've learned how to do expected value. Tomorrow's the review. Test is Wednesday. I'm going to stop the video. That's all I got for you for today.